My name is Kieran. The title of my project is Light Speed. The question I am trying to answer is, what is the speed of light? I became interested in this project because light is the universe's speed limit. Nothing can go faster than it. It's the fastest thing in the universe. Its speed is used throughout different topics of physics, including special relativity. The way I went about answering this question is using a microwave. You see, microwaves engulf your food with microwave radiation, a form of electromagnetic radiation, or light. During my research, I found that all forms of electromagnetic radiation go the same constant speed, so it wouldn't matter if I used one form or another. Then, from my research, I reasoned that the hypothesis that if light is the universe's speed limit and constant, then the speed of light should be going at an immense speed. So what I did was I put marshmallows into a microwave and let the marshmallows get a crevice. The distance between two crevices on the marshmallows would indicate the wavelength. The wavelength was necessary to find the speed of light because if we multiply the wavelength and frequency of microwave radiation, we would get the speed of light. On the back of the microwave, it told me the frequency of the microwaves coming out of the microwaves since the different ranges of frequency correspond to different forms of light. Next, I found that the wavelength of microwave radiation is approximately 12 centimeters using two approaches. The first one was having the microwave radiation flow into the microwave for half the time, and the second was having the microwave radiation flow in the microwave for the whole time, and each approach was done 30 times each. The former got me a wavelength of approximately 11.6 centimeters, and the latter was approximately 11.94 centimeters. Then, when I multiplied the result by 2.5 megahertz, the speed of light I found using the first approach was 95% of the speed of light, and the other was 97. I found out that the speed of light was around 292 million meters per second. So after the experiment, my hypothesis turned out to be correct because the speeds I found were very immense, after all. If I were to do this again, I would use chocolate bars instead of marshmallows. This is because when I was using marshmallows, it was hard to look at them and distinguish the difference between the bumps on the marshmallows and the crevices, except for the fact that the melted parts were the melted parts were the crevices. Chocolate bars flipped over have a flat surface, and it would be easier to see that, and it would give more accurate results. Furthermore, I would redo my experiment. With the right money, I could get a pulsed laser and send light to two light detectors, measure the difference between them, and use an oscilloscope to find the time difference between the two pulses. Next, I think that I would continue this project and find more useful applications for the speed of light. I could use this newfound knowledge from this experiment and study the stars and determine the light from the stars of the past. This knowledge would benefit society because tons of scientists and researchers use this constant to understand how the universe works and how it came to be. The cosmic microwave background was created by the Big Bang. This told us how old the universe is. We wouldn't know that without the speed of light. The speed of light is so useful throughout the scientific community, and without it, we wouldn't know half the things I just told you.